Good morning, participants. Am I audible? Am I audible? Audible. Huh? Uh,
Yes, madam, you're audible.
Today, we have our keynote speaker, Dr. Sridhar K., Vice Principal, Head of the Mathematics Department of KVG, Sulya, and he'll be addressing us on graph theory. Tomorrow, exactly 10 o'clock, we have Mr. B.S. Dayanand, Assistant Professor, Department of Chemistry, Srinivas Institute of Technology, Valachil, Mangaluru. He will be addressing us on the topic electrospun nanomaterials and their applications. On 6th, we have Dr. Surya Narayana K., Professor, Head of the Department of Physics, Srinivas Institute of Technology, Valachil, Mangaluru, addressing unmasking the physics around us. On 7th, we have Dr. Raghavendra A., retired Associate Professor, Department of Mathematics and retired Principal, Purna Prajna College, Udupi, and addressing graph theory for engineers. I request all the participants to join us in all these 5 days and make our FDP successful. Within a short while, we will start today's session by Dr. Sridhar K., Vice Principal, Head of the Department of Mathematics, KVGC Sulya, addressing on graph theory for engineers.
Hello.
Welcome back. Here I request our keynote speaker, Dr. Sridhar K, Vice Principal, Head, Department of Mathematics, KVJ College of Engineering, Sulia, to enlighten us with his keynote address. Over to you, sir.
Good morning to all. In the beginning, once again, I take this opportunity to thank my friend Dr. Kulkarni sir for giving an opportunity to address address the keynote address. But my topic is not in graph theory for engineers. That topic is covered by Dr. Raghavendra Seventh. So this is just a general topic I taken in this keynote address. Just I have shown that trailer of this actual my talk in this inaugural function. Just now is the continuation of this. Just I mentioned the role of basic science faculty members is just like a supporting staff or supporting faculties in an engineering college. But another name comes to my mind about our role in an engineering college is it is just like the role of a salt in any delicious food. That is, the role of salt in any food, the presence is not always observed, but its absence is always mentioned. So if the food is very good, even though it may be dosa, idli, water, in maybe, if it is very good means the credit goes to the cook or the cooker, the cook used, or the rice quality, but not about the involvement or presence of salt. But if salt is not there, immediately it's complaint. It is not good, it is tasteless. So like that, the role of basic science faculty in an engineering college is just like role of a salt. That is, presence is not appreciated, but absence is surely observed, noticed. Even engineering students, after completion of this degree, if you get success, you may not remember the basic science department staff members. But sometimes, if you fails in that entry process, that means in any test, that different test they have to face, if it fails there, then you complain. My mathematics knowledge is not up to the mark. My basic science knowledge is not up to the mark. Because of that, I didn't get that. So like that, they complain about the failure. That means our presence is also like this. Our presence is never, it is appreciated, but absence is very absurd. So that is our role. But now, what it may be, as a basic science faculty members of this any engineering college, nowadays what we observe is that one problem, that is poor performance of the students. So what we observe in almost all colleges, in the first sem year, what we face is the poor performance of a student. That is, we usually compare it's not good, and we continue like this. Not only this, after completion of this first year, if you go third semester, there also, when they reach the respective department, there are also staff, they complain about the students, they are not doing well, their basic foundation not good. And if you just ask what you do, we say that there are also complaints. So they don't know simple logic. They know, we have studied this differentiation, all these things. But if the question is, if it is asked, what is the maximum current flow in a circuit, but they fail to give the answer, that means they don't know how to apply that subject studied when they face the problem. Like that, the complaints goes like this. If you ask that PUC staff members, they also complain. So input is not good, sir. Students are not good in basic thing, foundation. So everywhere we used to complain the students. But when I heard this type of complaints about the students, they are not good, not doing well, then one joke come to my mind. The joke is like this. There was a pair, husband, wife, but after long togetherness, the wife, the lady, got on suspicion that his husband is not hearing well. His ears are not working well. So he had an idea that something is gone with ear. So what he did is, so just her friend, also one doctor, he consulted, he asked and explained the problem. In my husband, for any answer, I have to repeat the question thrice or fourth, otherwise can't hear. So that was the problem faced. Then what happened? That doctor wanted to see what exact problem. She told to her friend, you do one thing, I need the exact distance from where your husband is not hearing. So for that, she told, you do one thing, you just measure the exact distance. For that, you have to do an experiment. What the experiment is, just ask your husband that question at a distance 50 meters away. If it's no response from him for that question, again go 10 feet forward, again ask the same question and see what is response. Again no response, go again 10 feet front, again same question you ask. Then identify the exact distance for which he can hear, and what is the distance from that is not hearing. That was her suggestion. So this lady tried to get this answer for that. The next day itself, when her husband is reading a newspaper on a sofa, looking the TV, she just tried to see the distance from where he's not that listening. So for that, he just measured in advance 50 meters away from him. And at a 50 meters, just one question asked with the husband, re gantestaito. Then no reply. Then what she did is, again 10 feet front she went, again at a 40 feet distance, again same question, re gantestaito. Again no response, just her husband looking only, no reply. Again 30 feet. At a 30 distance, same question asked, re what gantestaito. Again no reply. but husband looking towards her with angry eyes, no reply. Again, she 10 feet went front and at a distance 20 feet asked the same question, re-contested. At that time, that husband with a very beeping just answered in a ಕಿವಿಯನ್ನು ಹೊರಟೆ ಹೋಗಿದ. 3 ಸಲ ನಾನು ಹೇಳ್ತಾ ಇದ್ದಾನೆ 8 ಗಂಟೆ 8 ಗಂಟೆ 8 ಗಂಟೆ. The fourth time again asking. Then that lady realized the problem is not with the husband, problem with herself. So that was the thing. That means she then understood, oh, problem is not with the husband. So that is also maybe happening in this case, because we are all complaining about students, poor performance, not doing well. Why almost all students like that? So we also have to think where is the problem, whether with us or with the student. Otherwise, after completion of all this B degree, he has good, very good job. They are doing that. But entry level, what is the problem? So you have to think over this. Where is the exact problem? So for this thing, our role, as I told, as a basic science faculty department, you have to get good foundation. So to see that problem, because another thing, everything comes and, as I told, just changes. Everything changes. As per the changes, you have to adjust. In the beginning, how the changes happened in the syllabus also. I joined for the first time as a lecturer in mathematics. That time, our rank given is only lecturer for mechanical department for 6th semester in 1988. For that time, the mathematics subject was for a 6th semester. The subject was Fortran programming and numerical analysis. Fortran programming, that was my elective subject in MSc. Nowadays, if you ask what is programming, we don't know. I don't know the spelling of also, because forgotten everything because of the change. So that time, the subject for 6th semester. After that, after 2 years, it's changed and reduced to 5th semester. That time, no computer science, that branch, civil, mechanical, electrical, and electronics. For all the semesters, mathematics was common. But in that 5th semester, what the subject taught, that entirely probability and statistics. And that was very good subject that time, because students used good, score good mark also. So that subject in that probability theory, usually that's in statistics, question asked just state and prove central theorem, derive F distribution, derive T distribution, derive chi-square distribution, and all derivation they asked. But students loved and they got good marks in almost subjects that time. Then later, when V2 started, that subjects are restricted only up to 5th semester. No, 5th semester mathematics. That time again, in final semester, students love to learn mathematics. That in 6th semester, they used to take elective subjects. But after that, it's up to restrict to 4th semester. In 4th semester, what they did for all the branches, common subject in the beginning. But later, after 2 years, that respective department HODs, they gave a suggestion to teach or give some mathematics section depending on the branch. But that time, we itself made a mistake. Some that senior faculty members were writing textbooks, they opposed, because they have to write separate textbooks. That was the reason. And they opposed and made it common to all. Later, when the result was poor, what is that continuation happened is, in every subject revision, the same subject, something remaining. If the student found difficult, derivation, it is gone. Like that, it is decreased. But when the contents decreasing, the number of failures is increasing every time. At the end, in recent 2 years, what happened, all of you know. So they told, we don't want mathematics itself and not need science also. We alone we go. But at the end, we succeed to restrict the chemistry. Everything is there only in the first year. And that in the beginning, up to 6 Sorry for the disturbance. Think just given a flashback about what happened. Now let us see what to do. So this faculty development program may help to change ourselves in the future. So first, let us discuss we are what? Because in a engineering college, just I mentioned, our role is supporting staff. But in an engineering college, we are treated as not lecturers. Nowadays, we are all professors. So just like, ladies and gentlemen, there is a professor post everyone. There is the highest academic rank given by the university. So the difference between lecturer and Hello. Hello. Slideshow. Once again, sorry for the disturbance. So, just I told what the difference between lecturer and professor. Now we are all professor with more responsibility. So professor means should have research responsibility. So not a just a lecturer, we have more responsibilities, teaching as well as research responsibilities. Then only is called as professors. So in the beginning, we are called as assistant professor, associate professors, and professors, not lecturers. So that you have to know in the beginning itself. Now we shall see what the modern definition of teacher. Teacher means don't think that just one who teaches, and lecturer means one who lectures, but lecturing. But now it is new definition that the teacher is one who collects, collates, analyzes, synthesis, and transform the curriculum information in the way and manner such that the student can understand and apply it. So the last one is important, not only understanding and applying this. So that responsibility we have. So not only just explaining, it must be in a such a way that should they understand and apply it. Then the question comes, who is the student? So the student definition is one who receives knowledge imparted by the teacher, comprehends the knowledge, verified through workshop or lab, practicals, write learning notes, and reproduces to the examiner. He is treated as student. But nowadays, what happening is that the student is not as called as student. Another name comes to this, that is, especially in technical college, he is now stakeholder. So we can't say he's a student, he's a stakeholder. So even though the teacher makes mistake, this is considered as student's mistake. Even though student makes mistake, then it is not student mistake. So it is treated as teacher's mistake. We have to make him to get all these qualities. So that is the responsibility of a teacher. Even though we are professor, we are treated as teachers. Now, what about basic science? We are all basic science faculty members. So what is our role is very important. As I mentioned earlier, without basic science, no engineering, because that is the fundamentals how to give them. So we have a very important role. Without knowing the basic science and mathematics, definitely the engineer never become the student after completion of this a perfect engineer. To become a perfect engineer, the basic knowledge of all this science and mathematics very much essential. Now, not only this, after completing this, for research in engineering and also for all developments, this science and mathematics are very, very important. That foundation. So our aim is to give a good foundation. Now, see, then what is our role? Our teaching role is just like, especially because in all the students enter to engineering institution, in the first year they comes under basic science faculty members. We have to see them to grow in a multi-dimensional. So our role is just like preparation of paddy land. That means paddy land preparation means we have to see how to make the earth smoothen. So you have to, it must be well tilled soil you have to prepare. For the snow, plowing is required and removing the weeds also required. And you have to make the earth very smooth, flooding of that water is also required. After that, if you plant that, then we get a good result. So just our role is also just making paddy land. So this sentence usually mentioned by famous mathematician of India who that started graph theory for the first time to India, that's Sampath Kumar sir. Dr. Sampath Kumar sir. He's no more with us. But whenever the faculties, that means faculties go for approach him for his help for research, used to say, ಗೊತ್ತೇನಪ್ಪ ನಿನಗೆ ಗದ್ದೆ ಕೃಷಿಯಲ್ಲಿ ಫಸ್ಟ್ ಏನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಗದ್ದೆಯನ್ನ ಸ್ಮೂತ್ ಆಗಿ ಉಳ್ಬೇಕು, ಉತ್ತ ನಂತರ ಪೈರು ನಟ್ರೆ ಅದು ಉತ್ತಮ ಬೆಳೆ ಬರ್ತದೆ. ಅದೇ ರೀತಿ ಬಿಫೋರ್ ಕಮಿಂಗ್ ಟು ದಿ ರಿಸರ್ಚ್ ಯು ಹ್ಯಾವ್ ಟು ರೀಡ್, prepare yourself well. So that type preparation you have to make the engineer students in the first year itself. That is our role. So first you should know what to do. So by knowing this type of basic science and that mathematics in the entry level, the students should that surely get that problem solving skills and developing another skill. Everything is available. So that is our role to provide them. But the question is how to achieve it, how to do. We have to see that we are all that entered the technical institution after our MSc or BSc from a degree college. That means we got training from that is academic universities. So this academic university different, technology university different. You got training from there. There they taught, our teachers, they taught only how to get knowledge about academic matter, about research matter. But here we are teaching about that technological students. So we have to change the style of our teaching also. So we are teaching them applied science. So if you teach how to teach, that means that should be like this. Any fundamental science should be taught in a technical university in a way somewhat different from the routine typical for academic universities. It must be lectured with a relevancy to engineering. Otherwise, what happens? It is not an applied science, just like a textbook with the formula and that universal constants. So I have to know this one while we're teaching for a technical college. So to better prepare the student for engineering, basic science subjects like physics, chemistry, and mathematics should be emphasized. A stronger focus on real-world applications and problem-solving skills, design thinking, and integration with engineering concept, moving beyond purely theoretical knowledge and incorporating practical exams relevant to various engineering disciplines, which are essential for understanding and applying complex engineering concepts throughout their studies and future careers. So I just told you have to do, you have to do. But how to do this? For that, I'll give some illustrative examples. Being a mathematics teacher, usually what happens in the first semester, several subjects are there, especially mathematics. The first semester, the first module is about polar coordinate system. Usually how teach? Just we say what is polar coordinates, what is the radius of curvature, what is the formula to get radius of curvature of a curve, or what is the pedal equation, like that formula, and we train them to get the answer for a problem. We are not training what is that. So that must be done. For example, usually we ask a question in the exam, find the radius of curvature of a cardioid, or radius of curvature of, or not radius curvature, it may pedal equation of a cardioid. But you are not mentioning or teaching them what is cardioid, how it is obtained, how to construct that, what is the application of this. This must be mentioned. For example, what is cardioid? Actually, it is happened like this. In machine, you have seen, suppose there are two tools with the circular tools. One may rotate in another one. Another circular tool, what the figure obtained with respect to a point moving on that is called as cardioid. That means how to illustrate for student. We can say like this, take a circle and take another circle with same radius, mark a point on the second circle, so let it be this point. Suppose that the second circle rolls around the first circle with the circumference. But when the circle rotates or rolls on the another circle on the circumference, this point also moves. You just observe the path taken by this point, how it moves. Suppose that this circle is after some time it reaches here. Then what about this point? It also, when just takes a move, it starts from this point. It just come like this, and it may reach somewhere else, this point. This is also moving. When that same circle reaches another point, suppose that it reaches here, then what happens? That same point, it may reach somewhere else. Again, that circle may reach another point, reach this junction. So what happens this point? It may reach here. Again, it will continue like this. See the movement of that point. At the end, when it's complete one full rotation, just mark that points how it is moved. So it takes a shape of this. See the moves how this you obtain means this shape is obtained. So this shape is called cardioid. So we have to illustrate the students what is cardioid, how it is obtained, because the rotation of one circle on the another circle. So we get a circle. How we obtain? Only because of the movement of the circle and that point marked on the first still take this curve. This is called cardioid. If you just say this is not enough, you have to mention what is the use of that. Because in the engineering syllabus, when it's framed, I was a member of this BIOS member. Because of the nth moment, we prepared that. We not change it must, but in the beginning, I mentioned that for every branch, you have to say the application. In our inaugural speech, our principals are told application you have to mention. So we should know where these cardioids are applied. So how it is cardioid obtained means because of the rotation one circle on the another circle, it has some important properties. That the cardioid has several unique properties, including its reflective nature, where the rays of light or sound waves entering along the axis of symmetry are reflected back through the focus of the curve. Additionally, it has a single cusp and origin and a single loop. Because of that, it has some interesting property. And we see some application like this. Some of the common field where card is used is acoustic. That means in microphones. In microphones, if it is designed such a that here the cover is that, the inside it may be a shape of cardioid. If it has a shape of cardioid, it is maximum receiving capacity. Because of that, instead of giving two microphones, two singers, one is enough, because from the front it maximum that receivement is that. But not only that, because of that shape, the sounds at the back it reflects, the rejects. So if the near some noise is there, it not be received from this microphone. So this type of application can see. That is in cardioid. Not only one example of cardioid microphone is Shure SM58, commonly used by live performers. It is designed to focus on the sound directly in front of while minimize the pickup sounds from the sides and rear, thus enhancing the vocalist's voice over the surrounding noise. And why this means the cardioid mic has a useful pickup angle of 131 degrees. So it can accommodate one or two singers and is forgiving enough to still pick up a vocalist with a wandering mic technique. So this type of application it has. Not only in that one, another in antenna design also. If it has antenna design to control the directionality of the signals, several applications there. In radio station, it might use a cardioid antenna pattern to focus on the broadcast in one direction to reach a targeted audience while avoiding interference with other stations. So this is the application that cardioid in antenna design. Not only this, optics also, we see several applications here. I'm not mentioning everything. So these are all very important in optics. Not only that, in photography, this also helpful for a full-time setup. This picture. These are application. If I say all these things, someone may complain whether it's possible to teach all these things in first semester because you have given only 4 credit. With the 4 credit, whether it's possible. But thing is, we should not teach all these things. What you do is you have to give opportunity to the students to learn this, because in assignment, assessment is there. There are two options. One is to write assignment. Another one is for other thing. So what we can do is we can simply give this type of assessment for the student to tell about the application, to write the application about this. We can make assessment to students. One is assignment, another is this one, but we can't get time to teach all these things. So several application for every subject. In the first semester, I taken this cardiac, another application just to tell. If you just this type of student, they study themselves and present in front teacher, they get interest in the subject. So this type of applications there, then can get interest and they love the subject. If they love the subject, definitely they study. So this is one my suggestion. So instead of teaching, we can give this one as assigned assessment. That means in assessment two top top you have to cover. One is assignment, another is assessment. Let them write for every subject. You can make it a group also for 3 or 4 students given. Several topics you can give in first semester. Another example, usually Taylor series. How the question asked, how you teach is, just we say Taylor series of f of x is given by a naught plus a1 etc. Blah, 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 like this. We just let them to get the points how we get the Taylor series. But we don't tell what is this, where you need the application. Someone may tell, I'm not telling all. Right? If you're doing it well, continue like this. If not, try to tell this type of applications. Taylor series means what? Taylor series, why it is used? Very important chapter, because the Taylor series is just an approximation for all the signals. In mathematically, we say it's function. Usually, a function is treated as technically a signal. So a signal function means if some input and output is there, there should be a relation. A relation is usually say x and y, and for every in a relation, if unique correspondence is there, then it's called a function. Whenever there is a function, it is expressed as a relation y is equal to f of x. But different of relation may be there depending on this nature, exponential, logarithm, everything is there. But whatever the functions given, we can approximate with a polynomial. Polynomial is a good approximation for whatever happening, because we should know what in a polynomial, which is in a curve with up and downs, just like a wave. It moves whatever happening throughout that atmosphere through a wave. So wave, how it goes with up and downs. Sine wave is there, cosine wave is there, but there is a limit for that. Maximum value is 1, minimum value is -1. But for polynomial, no restriction. So anything can be approximated by polynomials, and it is used to solve all type problems. For engineers also, for every approximation we can use this. That is the use of Taylor series. So in engineering, everything we don't want the exact answer. What the distance from Sulia to Mangalore means, we can say it is 87 kilometers or 88 kilometers or 90 kilometers, what it may be. Only we need approximate answer. We don't want the exact. So in any engineering problem, what we need is approximate answer. For all this approximation, Taylor series is used. Say how it is means, depending on the topic, it varies. When exact solution to a problem are difficult, then we can get an approximation solution by making use of this type of series. That is called Taylor's series. How it works means, in circuit analysis, approximating voltage or current behavior, it is done in signal processing, filtering the design, mechanical design, modeling system dynamics, and heat transfer analysis. Everywhere we need. By expanding that function means, as I called, it may be that signal, what it may be, when there is a relation between two variables, one is dependent and is independent, means you can use this type of approximations. A function around a specific operating point, engineers can study small deviation in the system behavior. Not only that, modeling small oscillation of a system in mechanical by approximating the system equation of motion using a Taylor series expansion around the equilibrium point. In signal processing also, this is useful. In computational physics also, it is useful. It can be done in various ways. So all this in machine learning also. And engineers often use Taylor series to approximate the behavior of a system in control theory, electric circuit, and structural analysis. It's also used for signal processing and filter design. The purpose is getting approximate answer. So again, as I told, it's not possible to explain everything in a class because of the time restriction, but we can give this one as assessment or self-study. If you say self-study means never in a study. If you guess assessment, definitely that study. Then also I can understand when they produce by getting all this from that Google or anywhere it's available, then we can also learn. So that is about the first semester. Another, I'll say a short crime story where mathematics used it. With the minimum time, I'll try to finish the very small story. So once burglar robs a bank. So here a lady is sitting in a bank, and the lady also thief also robbed that lady. So don't mistake with me, because there is a 35% for everything, the ladies. So it is lady photo is given. So what happened after robbery? She escapes in a gateway car. Then what happened? A police looks that he tried to caught her, that thief. But good news is it's not possible to catch her, but he succeeded to take a photo of that car. But same time, there's a bad news. Photo is blurred. It is not visible. What the car number is not understood. Then the entry of hero, that means mathematician. He came here. How to solve this? Engineer problem? Asked the mathematician. He entered. He tried to solve this. He modeled for this. He tried to model this blurring process. How it is done? Usually in mathematics called f, h, etc. Original function figure taken, let it be f. Because something it is blurred, take this function as f. So that through which it is blurred, take it as g. And blurred image, you take it as h. So how we get blurred image? That is because of convolution of f and h. So usually in the subject Laplace transform, Fourier transform, there was a chapter, it's called convolution theorem. Since students find difficult, they remove that. But very interesting, very important subject, that's convolution theorem. We have to tell them what in by convolution of functions. So this is happening here. We know when two trains go parallel with the opposite direction, who are sit inside the train, when the train passes, we hear a sound, heavy sound for a few minutes. That is convolution of sounds. How convolution of sound happen? One train moves one direction, another train comes in another direction. Now for a moment there is a convolution. So that is convolution sounds. Similarly here convolution happened. One photo, original one, another there is blurring function happened because of that convolution. That because of the convolution, blurred images happen. That is h. So mathematically, you know how to define this convolution. This h of x, we can get it. Blurred function. How? F of x minus y means g of y in one direction. F of x minus y goes the opposite direction. If you multiply integrate, that means eliminate y, we get this function h of x. How much is blurred? Now to get the original one, what to do? Take the inverse of this function. If we invert, we get the blurred function. That is what happening in image processing. You know image processing, there, this mathematics involved. You have to tell the students like this. They may get some interest. So that is about that convolution. So another one, that L'Hopital's rule is there. That again we are teaching the first semester. Usually someone used to call this L'Hospital rule, but don't pronounce like this. It is L'Hopital rule. H is silent there. So famous mathematician name. So usually we know, we just teach the student how to evaluate, but most students don't write in the exam because without knowing what is actually it happens. 0 by 0, infinity by infinity, where it comes like that. But usually this type of application seen in mechanical engineering, almost all subjects, to see the efficiency of brake gear or gearbox, to see the efficiency, what to do is we take a ratio of input that function and output function. If take the ratio, when at a point, if you take the limit of this, sometimes we get the answer like this. It may be 0 by 0, infinity by infinity, no value at all. It is not defined. In that case, how to measure the efficiency of a gearbox. What to do? We there use that Lapisal rule, especially to remove this 0 by 0 form or infinity by form, so that we can get that efficiency of a gearbox. If you just tell the application like this, definitely student get interest on this. In circuit analysis also, when calculating correct current or voltage behavior in a circuit at a specific point, the resulting function might lead to inductor form. There what you need is you have to apply this rule and you have to find the actual limit. That means actual uh, current behavior. Similarly, mechanical system I told, when out power divided by input power, that is called efficiency of a gearbox. That is also when it takes 0 by 0 or infinity by infinity. What you mean by 0 by 0 also I have to mention both the numerator function, denominator function simultaneously reaches to 0. If the numerator reaches 0 faster than denominator, the answer will be 0. No effect there. Or the denominator reach faster than, then again different answer. Simultaneously is 0, then only this problem arises. There what to do? You remove this by that rule. So that is application mechanical system. Signal processing also, it has application. In fluid dynamics also, it has application depending on the problem. So our rule is just like giving a stone. We can give the shape depending on the that Shilpi. It may be Vishnu or Shiva or Maheshwara, whatever it may be, the stone is same. Like that, we have to deliver the content depending on the subject. The shape is different. These are all application, but today's this workshop is on that is that recent trends or topics in applied science. So I have to touch some part graph theory and not give any detail because the resource person, Dr. Ragendra sir, is going to explain everything about this. Simply some idea I give about graph theory, nothing else, because it's a very important subject nowadays. Because as I told, changes happen. The introduction of graph theory is found long back. So usually engineers are treated as problem solvers. The main goal of that work of an engineer is to solve the problems of a society. But this subject graph theory also started while solving a problem. So there was a big problem, non succeeded in solve the problem, but for the first time Euler succeeded to give a structure through graph theory. Graph theory means just a relation about the objects. We are saying whatever the problem logical is there, it can be solved by graph theory. So everywhere used it. No, that subject left without graph theory. So very important subject. So it is just like a sea. We can take 1 cup of or 1 mug of water. We can do experiment depending on the subject. So I'm not mentioning about this one. It's a very big subject. What is that? That resource person may explain. So graph theory has been growing and expanding as an active and dynamic branch. In fact, graphs are efficient mathematical models for analyzing real world problems. Real world problem is nothing happening. Everything is because of this one. So just some application I listed here, graph theory applications, not all. One is main, you have to see Google Map. In Google Map, you know, if you want to go to a place, how we move. In a car, we put that mobile set, starting point you have to mention, where from where start, where the destination reach. Then this Google, that it gives every direction where to go. It gives how it works purely through this graph theory concept. Here, the intersection of two roads taken as vertex, we call vertex in a graph. And if there is a road between two places, that intersection of roads, then it's that connected by an edge. So when a place is given to start and also a place to reach, it works through an algorithm. It is called discourse algorithm. It gives a shortest path from a place to another place. From Mangalore to Sulya, several roads are there. Through Kasaragod also can go, via Subramania also can go, Putra also go. If you just give to Google, it's see what are the nearest vertices with the nearest distance with all traffic problems. And next you see the next distance, it go like this and identify the shortest path with the minimum distraction, and you can reach there. We are all experienced this, how it works, only because of this graph theory. In Google Map, not only that, in Facebook, in graphics, in all this modern, that image processing, artificial intelligence, machine learning, deep learning, everywhere. I have not mentioned here. Totally, I mentioned computer science. So this is the bus. For all this graph theory works. Computer network, engineering, math, everything. So that is the application of this. So in real life also, we can use it. Say, for example, in university, VTU, you know how to conduct the exam. Several subjects there, same student writing several subjects. We have to see the minimum days required to control or to give the timetable for that. This can be also done using this graph theory concept. One simple example I show you here. So here there are 11 courses, some subjects. The one student you have to write more than one, total 8 subjects there. If it is given like that, the question is find out the minimum days required to complete this examination without any ambiguity. If you know that graph the concept, immediately can say that only 3 days are enough. How? See this picture. So there are 8 such subjects shown in vertices. If there is a ambiguity, you can show by line. And what is represent the distinct colors? It is called coloring the vertices of a graph. There is a chapter like this, several applications. See, here only 3 colors used, shows that only 3 days are enough to complete this exam. So whatever the exam happening, we can do this type of this. Not only this, several exams in your live life also. I done one that graph theory work to know my father's fathers after 10th one. Who is that? I can say his name is Venkatesh, because I have that picture, but I am not going to show this here. So because the time constraints, this all work that slide I skip. Now I will finally come to this last but one. So because after this, usually we see several changes. I mentioned about this. Nowadays also we changes are there. Earlier that entry also nowadays everywhere, if you ask the question where are you going to engineering college, means usually they say computer science, no mechanical, no civil. If you continue like this, what next? At the end, there may be a place for STEM. So what is STEM means you should know. STEM is the education where which are equally treated: science, technology, engineering, and mathematics. Next, you may need this one, because everyone is, there is no supporting staff, everyone is equal. This type of education may be required. Already in some countries started. Now UK, US, Singapore, and other countries they said. In India it may come. So STEM means all are treated as equal. Everyone knows the knowledge about all this: science, technology, engineering, and mathematics may go together. With this, I go to the last slide. That is, thank you all.
Thank you, sir. We are extremely sorry for technical inconvenience you have faced during the session. Now session is open for the queries.
Good afternoon, sir. Good afternoon, sir. Good afternoon, sir.
Yeah.
Good afternoon, sir.
Not audible.
Sir. Good afternoon, sir. Sir, good afternoon.
Session is
Good
open for
afternoon, sir.
queries. If at all, any participants, if at all you have any queries, please feel free to ask.
Sir, what will be the next session? On which topic the sessions will be? And you will give any PPTs which you have presented today's class, you will send in the group?
Tomorrow. Any question? Yes, just.
Yes, sir. Just the representation what has done in today's session, you will
Okay.
send in the group?
Sent
It will
in
be
group.
helpful for us. Hello, sir. Can you hear to me?
Now it's here.
Yes, sir. Sir,
What is the question?
presentation, sir, the presentation what you have did in this session, can we
Okay.
get it in a form of PDF in the WhatsApp group?
Okay. That should try. Right, no problem. Right.
Okay, sir. What will be the next session on the which topic it will be?
Most probably tomorrow, it may be 10 to 12. 10 to 12.
The topics will be, sir?
Tomorrow's
Excuse me,
topic.
madam, it will be chemistry session, and we will put the notice in the WhatsApp group. Please collect the information from there itself. And about the graph theory, if at all you have doubt, please ask with the sir. Resource person is there now. Please ask.
Yes. No, sir. And then today, in this today's session, little bit of physics concept was been not more introduced. The mathematical concepts were more introduced.
Hello. Today it is only
Hello.
keynote
Sir, the
address.
physics. Yes, yes.
Tomorrow at what time, ma'am?
Yeah, tomorrow from 10 to 12.
Mystery.
Yeah.
No afternoon
right.
session. No afternoon session, sir.
When will be the physics? When will be the physics?
Today
Ma'am,
no
it will
afternoon
be
session.
notified in WhatsApp group, ma'am.
Okay, ma'am. Thank you, ma'am.
If you have
Ma'am, is
doubts
our
or
attendance
questions
is
on
recorded?
this session, you can ask now, ma'am.
Ma'am, is our attendance is recorded?
Ma'am,
Hello.
it's recorded, ma'am.
Attendance, ma'am.
Yeah, it's recorded. Today's attendance also recorded, and
Recorded.
coming session attendance also recorded, ma'am.
Okay, ma'am. Thank you, ma'am.
Thank you, ma'am. Thank you.
Thank you.
It is my privilege to propose the vote of thanks on this special occasion on behalf of Departments of Basic Science, Srinivasa Institute of Technology, Valachil, Mangalore, and I extend my heartfelt gratitude to our esteemed resource person, Dr. Sridhar K., Vice Principal, Head of the Mathematics Department, KVG Engineering College, Sulya, for delivering such an insightful and enriching session on the responsibilities of basic science faculties towards engineering students, and also imparting the knowledge on and applications of mathematics in certain engineering applications. We truly appreciate the effort and time you took share your valuable knowledge with us. I thank everyone for their enthusiasm and keen interest in learning. So this concludes our session for today. We will resume tomorrow at 10 a.m. Thank you all for your participation. We look forward to continuing our discussions tomorrow. So,
Sir, will you provide any feedback link?
yeah, feedback link will be shared through the WhatsApp. There you can,
Okay.
open it and you can. Yeah. Thank you.